To design any clocked sequential circuit, we need to have some algorithm. What are those algorithms and what algorithm I need to follow? Let us try to see. The first and important point that we have to consider is the find input variable, output variable, state variable of the given sequential circuit. So this is the important parameter that you should know. Okay, you must have the information about the input variable, output variable, and the state variable. Second point is you should also know the number of flip-flop that are given in the circuit. Okay, and because the number of flip-flop decide how many state variables we can have. Okay, so you should have the information about how many flip-flops are there in the circuit. Third thing that you should know, what is the number of possible states? Okay, total number of possible states that we can have. Okay, so this is important thing that you should consider here. Okay, see here, there is one mistake. It should not be 2n, it should be 2 to the power n. Yeah, so the total number of possible states are 2 to the power n if the n number of n state variables or n number of flip-flops are there. So for n flip-flop, we can have 2 to the power n possible states. Okay, so not 2n. Okay, the next and important parameter that we should have, the find excitation of each flip-flop whatever we have. Suppose I have a 2 flip-flop, then I have to find the excitation of each flip-flop. Okay, the next step that I have to follow, use characteristics table and the excitation of flip-flop to find the next state. So I have to find the next state of each flip-flop with the help of present state. Okay, next step that I have to follow is I have to prepare the characteristics table from the equation of the flip-flop, and then that will be done. Okay, and the last step is assign the symbol like a, b, something like that for the different values. If it is 1, then it will be x. If it is 0, then it will be x complement. Okay, so these all are the states. Yeah, so it's not that much important. Actually important is like how we are moving ahead with these things. So let us try to yeah, so last step is prepare the state table and then draw the state diagram. So these all are the steps that we should consider while analyzing any sequential circuits. Okay, let us try to apply this algorithm to understand any circuit. Okay, suppose I have a circuit like this. Okay, if I have a circuit like this, can anyone tell me whether it is the Murray model or Millet model? Which kind of model it is, this circuit? Suppose I have a circuit like this, it is the Murray model or the Millet model? Anyone?
Murray model. Murray model, sir.
It is the Murray model. How you got to know that this is a Murray model?
Sir, x जो इनपुट है वो y पे इसका कोई आउटपुट नहीं आ रहा है एक तरीके से.
Absolutely correct. Absolutely correct. See here, x is the input of this one, this whole complete circuit, and this x is not controlled with the output combinational logic circuit. This AND gate is nothing but this is the output combinational logic circuit, and because there is no connection between this x and this one, if it is connected like this, let us assume if the connection is something like this one, like x is connected to this one, then we can call them this is the Murray model, Millet model. But because there is no connection between this input and the input of this output combinational logic circuit, so this is nothing but this is the Murray sequential circuit, because you will get 2 additional credit, additional marks. Okay. So now onwards, the additional bonus points will be awarded to the students. Okay, so Vikas will get 2 marks additional. Fine. So this is how how the Murray sequential circuit will look like. Now let us talk about if I have a Murray sequential circuit and if I want to design these things, so what kind of things we should understand or the things we should consider, especially while designing these things. So let us try to consider those things while designing this one. Okay. If you see here, as of now, I have a two flip-flops that has been used. So the total state variables we can assume is the 2 to the power 2, means the total 4 state variables are possible. Okay. So here I have a two flip-flop 1 and the flip-flop 2. Okay. And now if you see here, the flip-flop is like JK flip-flop, and we know that the characteristics equation of the JK flip-flop is QT plus 1 is equal to JQT bar plus K bar QT. So this is the characteristic equation of the JK flip-flop. We know these things. Okay, so let us try to solve this Murray sequential circuit. Okay, first thing what I have to do. Okay, first I have to find the excitation of JK flip-flop. Okay, so let us try to see what is the excitation of JK flip-flop. See here, I have a four inputs. One is the J1, second one is the K1, third one is the J2, and the fourth one is the K2. These all are the inputs. Okay, so let us try to write what these terms are. So if you try to see, J1 is nothing but this is ending of X, and the second input which is here, this is the Q2 bar. Okay, so the J1 is nothing but X into Q2 bar. Okay, so this is the Q2. Let me write in terms of T. So the Q2 T bar. So this is the J1. If we talk about K1, so the K1 is nothing but this is equal to 1. Okay, if we talk about the J2, J2 is nothing but this is, see here, J2 is the ending of Q1T, and this is controlled with the X, and we have inverted, so the X bar will be there. Okay, so this term is not, because this is X, so this will be the X bar, and here I have a Q1, so the J2 will be X bar into Q1T. Okay, and the K2 is equal to, if you see here, K2 is nothing but this is the J2 complement. J2. So see here, this is the J2 and J2 bar is the K2. So J2 bar is the K2. If you have any doubt at this point, you can ask the questions. Okay. So simply based on the inputs, whatever we have connected, we just got to know what is the excitation of JK flip-flop. Okay. Next thing. So this is the first step, that first parameter that we need to consider while analyzing the Murray sequential model. So important thing is, first I have to identify whether it is the Murray or it is the Millet. So we got to know that this is the Murray model. Then the second one is I have to find the excitation of JK flip-flops. Okay, so the excitation is given by this one. Next parameter that I have to consider is output of the sequential circuit. This is the output of the sequential circuit. If you see here, the output of sequential circuit is nothing but this is the Y is equal to Q2 is ended with Q1 complement. Okay, so the Q1 complement and Q2T. So this is the Y, output Y. Okay, so this is how we can write the output. Third thing that we have to do, I have to find the output of each individual flip-flops. Okay, so let us try to consider the output of flip-flop 1. Output of flip-flop 1 is the I have to calculate this Q1T. So the Q1T is equal to, if you see here, Q1T is nothing but so I have to simply find the next state output, Q1T plus 1. Okay, so Q1T plus 1, I have to apply this one. So the QT plus 1 is given by J Q bar okay, plus K bar and the Q. Okay, if we try to see here, J is nothing but this J is, yeah, J is the, for the first flip flop, this is the J1, and J1 here we got to know that it is X Q2 bar T. Okay, so the J, in place of this J, I can write X Q2 bar T, and uh, this Q bar T means the output of the same flip flop, and that is the Q1. Okay, so the Q1 bar T. So this is the first term that we should know. Yeah, about from this one, plus K1 bar, okay, K1 K bar plus QT. Okay, so what is this QT? Q1T is this one. So if we try to simplify it, plus K bar is nothing but this is the one. Okay, and
Zero, sir.
so it is 0, sorry, K bar is 0, so whatever the term will be there, that will become the 0. Okay, so the Q1T will become the simply something like this. Okay, see, because the K1 is 1, so the K1 complement will become 0, and because of that the other term will become 0. So this is how we can get the output of first flip flop. Now the next step is I have to find the output of second flip flop. What is the output of second flip flop? Let us try to see. The output of second flip flop will be, let us, Q2 T plus 1. Okay, Q2 T plus 1. I have to apply the same formula again. So the Q2 T plus 1 is given by something. Let us try to apply here. So the J2 is nothing but this is the X bar Q1T. Okay, so X bar Q1T. So this is J, and next one is the QT. So that will become the Q2T complement. Okay, this is the first term. Second term, if you talk about K bar here, in this case, K bar is nothing but this is the this output, which is the we have already considered it. Okay, the output of the first one. Okay, so if you see here, this is the QT and ending with the X bar. Okay, so the X bar into Q1T is the K. Okay, and yeah, so this is the K. Let me check it again. K bar is, yeah, K bar is nothing but this is equal to J only, right? So I have to use the J2. So J2 is nothing but this is the K bar Q1T. Okay, and the next terminology is the QT. So it will become Q2T. Okay, so this is how the expression will look like. Do you have any doubt at this point how I got I calculated this one? Let me repeat it again. If you consider this equation, J QT Q bar T plus K bar QT. So the J means I have to consider J2. J2 here I have like X bar Q1T. Okay, and the next one is I have to use the Q bar, and because I am considering the second flip flop, the Q2 bar T. So this will be the first term. Second term, what I have to write, K bar like K2 bar. K2 bar is nothing but this is equivalent to J2, and J2 whatever we have already got it, like X bar Q1T. So this is the J2, and the second term is like QT. So the QT means the Q2T because we are considering the second flip flop. So the Q2T will come here. So this is how the expression will look like. Okay, so we got to know about all the variables, whatever we need here. Let us try to simplify this expression. If we try to simplify this expression, that will become, let us, what we can take the common. Yeah, we can take the common like X bar Q1T, and if I'm taking this term common, so I will have Q2 bar T plus Q2T. Okay, and Q bar this will become 1. Okay, so ultimately what result I will get? I will get X bar Q1 into T. Okay, so this is the output of this one. Now let us try to make the other things. So if you have any doubt in this slide, you can ask the questions, because we are going to use these expressions to design the other parameters like the characteristics table, transition table, and the state table. Okay, so if anyone has doubt on the equations here, you can ask. Okay. So the attendance at this stage will be recorded. Okay. Thank you. Fine. So if you don't have any doubt, let us consider the other things. Now let us try to make the first thing, that is the characteristics table for the sequential circuit. Characteristics table is basically prepared with the help of output of the sequential circuit, which we have considered before, and the output of both the flip-flops. Okay, so if you see here, output of the sequential circuit, output of the first flip-flop, and output of the second flip-flop, these three terms will be utilized to prepare the characteristics table. Okay, so let us try to see. Yeah, if you can recall here, the output of this one, that depends on the Q1 and the Q2. Output of the flip-flop one will depends on the X, Q1 and the Q2, and output of second flip-flop, that depends on X and the Q1. Okay, so based on these values, let us try to prepare the characteristics table. Okay, so how we can prepare the characteristics table, let us try to see. We need three important things. I need the Q1T, Q2T, and the X to prepare the Q1T plus 1 and the Q2T plus 1. So these three things are required. And we also need the output. Output, see, output depends on the, so if you can recall in the previous slide, the output Y was nothing, it was Q1 bar T into the Q2T. So this was the output Y. Okay, and if you can recall, the Q1T plus 1, this was X Q1 bar T and the Q2T bar. This was the Q1 T plus 1. And if you talk about Q2T plus 1, this was nothing but it was the X bar Q1T. So this was the expression which we have seen in the previous slide. Okay, now let us try to use all these things. If I can put some logics here, like, yeah, so because input and the present states, based on this, I can make the table like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay, so these all are the inputs and the present state. Now let's try to calculate the output. So what output I will get? Output means like this is the Q1 bar T plus Q2T. So this will give you the logic 1 if the Q2T is 1 and the Q1 is 0. Okay, so because the Q1 is 0, then Q1 bar will become 1 and the Q2 is 1. So the combinations where the Q1 is 0 and the Q2 is 1, that will give you the logic 1. So which are those combinations? If you see here, the Q1 is this one and this one, and the next combination is this one and this one. So in these two combinations, I will get output Y high, and for other cases, I will get 0. Okay, so this is how output can be prepared. Okay, if anyone has any doubt how I got this, so you can ask the questions.
सर ये फर्स्ट केस बताना सर, Q2 इक्वल टू 0 और Q1 इक्वल टू 0।
First case, okay. So see, we know that this y is equal to q1 bar into t plus q2 bar into t. To make this y1, what should be? Because we are ending it. So this component should be 1 and this component should be 1 to make y is equal to 1. Okay. So to make these two, this component should be 1. But it means the q2t should be 1. So q2t should be 1. Where the q2t is 1? This, and this. These are the four combinations where I am getting q2t is equal to 1. Now, if you see here, q1t complement should be 1. What it means? It means that q1t should be 0 to make output 1. So out of these four combinations, I need to check what are the combinations where I am getting q1t is equal to 0. So q1t is equal to 0, here I will get, and I will get here only. Here and here I will not get. Okay, so I have shortlisted only this combination, and this combination will give you output 1, and rest all other combination will not give you output 1. You got the point?
Yes sir.
Okay, so this is how you can come up with these values. Okay, so 1 is 5. Similarly, you can also prepare the table for the q2t plus 1 and the q1t plus 1. Okay, so q2t plus 1, yeah, first start with this q2t plus 1. Similarly, just you have to do like to make this one, q1 should be 1 and the x should be 0 to make this q2 1. Okay, so x should be 0. So let us try to see where the x are 0. So these are the four combinations which can have x is equal to 0. And out of this, I had to check what are the combinations where I'm getting q1 is equal to 0, q1 is equal to 1. So these two, can you, so there is some noise is coming. So some noise is coming from Rahul. Can you unmute yourself? Rahul? Some noise is coming from you. Can anyone tell him? Otherwise, I will remove him. Okay, fine. So I was discussing about the q2t. So to make this q2t, x should be 0, q2t plus 1, x should be 0. So these are the all possible combinations, and q1t should be 1. Okay, so out of all these things, q1t is 1 like this, and these two combinations which are giving q1t is 1. So these two are the cases where I can have the q2t 1. So this is 1 and this is 1. Rest all other combinations are 0. Okay. Now, similarly, the similar approach will be applied to get the q1t plus 1. Okay. Then let us see how the q1t plus 1 can be. To make this q1t plus 1, x should be 1. Q1 should be 0 and the q2 should be 0. So that the q1 complement and the q2 complement will become 1. So that I will get the q1t plus 1. Okay. So let us try to check. First case is x should be 1. So these are the cases where I have. Second case, I need to shortlist. Q1 should be 0. So q1 should be 0. So this and this one. Next, the q2 should also be 0. So the q2 should also be 0, and I am getting only these combinations. So after shortlisting, I am getting only this pair where I will get the all conditions satisfied. So at this stage, I will get 1, rest all other will become 0. So this is how we can prepare the characteristics tables. If anyone has any doubt at this point, you can ask the questions. How we prepare this characteristics table? You should know the things. So this is how the characteristics table is prepared. Okay. Next step is, once we are ready with this characteristic table, we need to prepare the transition table. Okay. So let us see how the transition table is prepared. Transition table preparation is based on the, yes, this is nothing but this is the rearrangement of the first table. Okay, the rearrangement of the first table means like simply the Q2 and Q1 can have the four possibilities: 0 0, 0 1, 1 0, and 1 1. So these are the possibilities. If you see here, I have x is equal to 0. Okay, so if x, we'll see here, Q2 Q1 is equal to 0 and x is equal to 0. In that case, Q2 t plus 1, I am getting it is 0. So Q2 t plus 1, I am getting it is 0. And Q1 t plus 1, I am getting it is 0. So 0 and 0. Okay. Next one is like Q2 and Q1 is 0 1 and the x is equal to 0. So that will become 1 0. Okay. 0 0 and 1 0. Okay. So this is the table for x equal to 0. Similarly, for x equal to 1, simply this will be replicated, right? Whatever the terms I have here, this will be replicated over here. So this will become 0 1, 0 0, 0 0, and 0 0. So this is how we can make it for these two cases. Okay. Now let us talk about the y. Y is simply, if we see here, y is replicated like this one, 0 0 1 0 and 0 0 1 0. For both the cases, I am getting the same kind of output. So I will simply write 0 0 1 0. So this is the output table, and this is how the transition table is made with the help of the characteristics table. See, the transition table is nothing but this is the different kind of representation of the characteristics table for two different cases of the input. That's it. Okay. So for x is equal to 0 and x is equal to 1, that has been prepared. Now, once we are ready with this transition table, we need to prepare the state table. Okay. So the state table need to be prepared. And what this state table is, let us try to see. Yes, to prepare the state table, I just told you, we need to use some state symbols. Okay, so state tables are nothing but they are in terms of symbol I have to use. Okay, so to make the state table, I have to consider the different combinations, like whatever the combinations I have used, I need to represent in terms of some symbol. So let us assume the Q2 is equal to 0, Q1 is equal to 0. So let us consider, I am considering the symbol A. Okay, for 0 and 1, I am considering symbol B. For this, I am considering symbol C. And for this, I am considering symbol D. So these all are the consideration whatever I can have. So considering these things, let us try to prepare the state table. So the present state, yeah, whatever combination I have Q2 and Q1, I can simply make it like A, B, C, and D. Why we are doing like this? Because if I have more number of, if suppose I have a 2 flip-flop, so the states will be 0 0, 0 1, 1 0, and 1 1. So this is easily doable. But if I have let us assume 5 flip-flops, so then combination will be 0 0 0 0 to 1 1 1 1. So the total 16 possibility will be there, and readability will not be that much easy. So to avoid that problem, we can use symbols to represent these things. So based on the present state, we can assign some symbol to all the combinations, and then accordingly you can check it out. Okay, so 0 0 has been represented with the A, this is represented with B, this is C, and this is with D, and accordingly we got all these stages. Okay, once we are ready with all these things, we can have a table on this. Yeah, so it can have X bar. Okay, so let us try to prepare it. I just told you 0 0 indicates A. Okay, 0 1 indicates B, 1 0 indicates C, and 1 1 indicate D. So this is the present state, and if x is equal to 0 means it represents x complement. X is equal to 1 means it represents x. Okay, so first I am considering the x complement. What it means, I have to consider this table, these two columns. Okay, I have to consider these two things. So because I have given 0 0 as a, so if you see here, the present state was A, and next state is also coming like A, so it will be reflected A here. Similarly, if present state is 0, 1, and the next state is 1, 0, and the 1, 0, I have assigned this 1, 0 as a C, so it will be C. The present state is 0, 1, which is the C, so the next state is going to become 0, 0, and the 0, 0 is nothing but this is the A. And the last one is, if the present state is 1, 1, the next state what I am getting is the 1, 0, and the 1, 0 is nothing but this is the C, so I need to write C here. So the AC, AB will come out for the X complement. Similarly, if I'm considering for the next stage, like for the X is equal to 1, so let us try to see what will be the output. For X is equal to 1, present state was 0, 0, and the next state is coming like 0 and 1, and the 0 and 1 is nothing but this is the B. Okay. Here next state is 0, 0. So this is equal to A, and A. So this is the expression for this one. Now let us talk about the output. Here I have a Y is equal to 0, and Y is equal to 0, that indicates Y complement. Okay. So I can write in terms of Y complement. Next one is also Y complement. Next one is Y and the Y complement. Okay, so this is how we got the state table. Look into this. If you have any doubt, please let me know. I will explain it. Anyone, if you have any doubt, please let me know. Just consider 0, 0 as a 0, 1 is a B, 1, 0 as a C, and 1, 1 as a D. That's it. And based on that, we got to know all the states here. Okay. Fine. So by seeing these things, we got to know this one. Now let us try to draw the state diagram, how we can have a state diagram. So I just told you, we can have a 4 present state. So let us assume the first present state is A. Next, let us assume the present state is B. Third present state is C. And the fourth present state is D. Yeah, because I'm using the Murray model. So in the Murray model, I have to give output below this state, right? Whatever the state I have. So that is why I wrote A, B, C, D at the corner side, at the top side. Okay, because I have to write the output as well here. I have to write outputs here. Okay, so that is what we can do. Now let us try to see what outputs we are going to see here. Sorry. See here, if the present state is A, so for X bar, I'm getting the next state is again A. Okay, so what I have to do here, present state is A, next state is again A, and the input, like the input is nothing but this is the X bar. So the X bar is the input, and the output which we are seeing here is the Y bar. So Y bar is the output. Okay, so this is the first state. The next state, let us try to see here. Yeah, the present state is A. The next state is becoming B if X is equal to 1, and again output is Y bar. So what we can do? We can simply, it will shift from A to B. Okay, and the input is X. Okay, and the output is nothing but this is the Y complement. Output is Y complement. So this is how we can make the second case. So now the first state is done. We have finished this first part. Now let us talk about the second case. What we can make for the second case. The present state is B. For X bar, next state is C. Okay, present state is B. Next state is going to become C for X bar, and the output which we have received here is, this is the Y complement. Okay, next one, let us see. Present state is B. Next state becomes A, and if X is equal to 1, so present state is B, next state is A, and the input here is X, and the output again here is Y complement. Now let us talk about the third state. Okay, so the second state is also, second one is also complete. Now let us talk about the third one. Okay, what this third one says. Third one is like the present state is C. Okay, next stage is A for X bar. So C to A here, C to A here, and this is for the X bar. Okay, and the next output here I can see is the Y, output Y. Okay, so the output here that will be reflected as Y. Okay, and again, if X is equal to 1 or X, then again the next state is becoming A. So this is valid for both the cases X bar and X. So that is going to be Y. Now let us talk about the last case, which is the D. The current state is D. Okay, current is, yeah, let me change the color. So the current state is D. Next state is C for X bar. Okay, and the output is Y bar, which is already there. Okay, and if you see here, the present state is D, the next state is A. Okay, so the next state is going to become A, and then we will have it X, and Y bar will be the output. Okay, so this is all about the state diagram, how it can be made.